So let's get started. And then if we have some people join, that is A-okay. So I have a couple of things I want to talk to you about before we get started with math today. First is that language project. So I've been talking to you about that. Today, your assignment in language is to work on pages 275 and 276. Those are the pages where you are going to receive all of the information that you will need to complete that project. So remember, your project is to, in some way, you have a lot of choice in that, show me what you know about the parts of speech. And you need to include all of the parts of speech that are on page 275 in your language workbook. Now, you had a lot of ideas. Some of you have already messaged me about those, and I've given you the A-OK to get started. So if you have another idea that was not given to you on the example list, just talk to me and let me know. And we can go from there. So remember, no matter what you choose for your project, whether you choose a poster or a booklet or a song, some of you asked about Prezi, some of you asked about some other things. No matter what you choose, you are sending to me a video. You have to send me a video file. So if you chose to make a poster, that's awesome. That's great. Your video should be you presenting the poster to me, just like if we were at school and you were to go up in front and present the work that you had created. So you need to present whatever it is you created. If you wrote a song, then you can sing your song and have someone video record you so that I can see it as well. If you created a booklet, you're going to do the same thing. You're going to present it to us. You're going to show us what is on every page and explain it to us, read it to us, so that I can see it in your video. No matter which project choice you choose, you should all send me a video file for the language project. If you have any questions about that project, please let me know. You can email me, you can send me a message, you can call me, you can leave a comment on Google Classroom, you can ask me to meet you on Zoom. Whatever you need to do to get a hold of me, please do that so that I can help you. Now, remember, that project is due next Friday, May 15. I am not going to accept it late. So I would make sure that you get started right away so that if you run into any problems or have any questions, that you have time to ask me about them. Okay, that's language project. Next week, I want to try something a little bit new. Now, I know that having school online is new for you, but it's also new for me. And so I'm trying to find the best ways that I can to help you learn. And I really, really, really love meeting with you on Zoom 3 days a week. But I think what might be a really good option for us as a class is if one day a week, instead of all of us meeting at the same time, if we meet in smaller groups. That way more of you can talk to me. Because sometimes when we meet all together, it goes so fast that not everyone gets a chance to answer questions or to tell me what they're thinking or to tell me anything that they're wondering about. So next week, we're going to try on Wednesday, just on Wednesday, to meet at different times in smaller groups. Now, I've created a schedule, and I'm going to share that with you right now. When this meeting is over, I'm also going to send it in the group chat. If for some reason you cannot come during your scheduled time, that is okay. Let me know, and I will change your time or the day, and we'll make it work so that you can be in a small group. I'm going to start from the beginning and say that whole thing again, okay? All right. I want to make sure that when we're meeting online, we're having the best experience we can. I really love meeting with you, and so I want to also meet in small groups. Next week, Monday, we will have a regular meeting at 10 a.m. with everyone. Wednesday of next week, Wednesday, May 13, instead of all of us meeting at one time, I'm going to meet with you in small groups so that you have the opportunity to speak more. I'm going to show you the schedule in just a moment. Friday of next week, regular meeting of everyone. Okay, so Monday and Friday, it's just like normal. I'm only changing up Wednesday. Okay, and that's just so that we have more time to talk to each other, more time for me to answer your questions, and more time for you to tell me your questions. I'm going to share my screen with you, and I'm going to show you that schedule. If you see that you are at a time that you cannot meet, we will make it work. So get a hold of me. You can call me today. You can message me today. You can email me today. You can comment today. I think those are the only methods of communication we have. But however you need to, you can get a hold of me and we will change you to a different time slot so that you can meet with us. Remember, I'm going to send this file right after this meeting. So if you forget what time you are, don't worry. I'm going to send this file. Next week, Wednesday, May 13, we're going to meet in small groups instead of one big group, okay? These are the groups I have. For 8 a.m., Alejandro, David, Sarah, Stephanie, Mario, Fiorella. At 8:30, Ariel, Donna, Christopher, Ferris, Juan David, Ramon. At 9 a.m., Luis, Omar, Diana, Madeline, Angel, Daniel. At 9:30, Paolo, Ian, Darius, Maya, Camila, and Valeria. And then at 10, Ana, Andrea, Melody, Sofia, Elias, and Juan Diego. That is for next Wednesday. Next week, Monday and Friday will be normal, just like always. If that time does not work for you, please communicate with me so that I can change it to another time for you and make sure that you're able to be in our class, okay? Friday, this week Friday, the normal 10 a.m. Monday, the normal 10 a.m. Wednesday, that's where it gets a little bit different, okay? I'll send you lots and lots of reminders in the group chat, so don't worry. All right. That is all the announcements I have for you today. So let's get started with math. You should have your math workbook. Today we're going to start on page 229, so turn there please. You should have a pencil that is well sharpened and ready to go, and maybe an eraser if you need that too. So make sure you get all of those materials. Last week, I reminded you that in the upcoming week, you may need a protractor. If you have one, please start looking for that in your home. If you do not have one in your home, that is a-okay. I have an online tool that will work for you, but I will need to teach you how to use that. So make sure that you let me know via text, call, or email so that I can make sure that you are ready for our class next week. I'll say that again. Next week, you need a protractor. If you don't have one in your home, do not leave your home to go get one. Just let me know, and I'll teach you how to use the online protractor. Okay? All right, so we are looking at page 229. It says areas of complex figures. Okay, does everyone see that page? Give me a thumbs up in your video when you see that. Give me a thumbs up in your video when you see the title that says areas of complex figures. Thank you. I'm seeing lots of thumbs ups today. All right, let's get started by reading where it says fact in the yellow box. Who would like to read that for me today? Ferris, would you be willing to read that to us today? I'll try to unmute you here. You're going to have to click accept where it says fact. Ferris, would you like to read or no? Go ahead and type in the chat if you want to. I'm trying to unmute you, Ferris, but for some reason it's not letting me. Okay. Ferris, are you there?
I don't want to read.
Okay, that's okay. Would anyone else like to read for us today? Omar, I'm going to unmute you. Go ahead, Omar.
To find the area of a complex figure, separate it into its simple parts. Find the area of each simple part.
Thank you very much, Omar. Okay, so I heard a lot of different words in there that I want to talk about. The first word I heard that really makes me think here is it says area. Right in the chat box, what does the word area mean? Go ahead and write that in the chat box. What does the word area mean? Area. Write that in the chat box when you know. What does the word area mean? Good. Camila got the first answer. She says the space inside a figure. I agree. Very nice. Let's see if anyone else has a different answer. The space inside a figure. That's what Camila said, and I completely agree with her. So if we look at this page, we're now talking about shapes that are a little different, right? We learned about the space, inside. We learned about the formulas that we can use to find the area of shapes that are normal, right? Let's talk about those. What formulas for area do you know? Go ahead and write that in the chat box or raise your hand on your video so I can call on you. What formulas for area do you know? You know quite a few now. Awesome. Great job. Juan David said A equals L times W. Okay, that's one area formula. And for which shape can we use that formula? A equals L times W. For which shape? Madeline, we're on page 229. 229. Very good, Daniel. That's for rectangles. When we have rectangles, we can use this formula. I see on here, let's see, what else? Omar said A equals S squared. That's another area formula. This little arrow pointing up, that's called a caret, and we can use that to denote when a number is an exponent. It's kind of telling us, put this little 2 up just a tad. That's called the caret, and we use it to denote exponents. So A equals S squared. That's an area formula. For which shape can we use that formula? You're welcome, Madeline. For which shape can we use A equals S squared? Good job, Daniel. That's for a square. When we have a square, we can use this formula. Camila says A, I think Omar said this as well. A equals 1/2 B times H. That's an area formula. For which shape can we use that area formula? 1/2 times B times H. Good. You guys all got that. I think Daniel, Omar, Camila, Juan David, and Ramon answered at the same time in like less than a second. That is for a triangle. We have one more that we've learned. I don't know if anyone's put it on here. Let me look through the chat really quick. I do not see it yet. Ah, there you go. Andrea just put it in. What is the area formula for, let's see, A equals pi times r squared? What shape is that for? Pi times r squared. Good. That's for a circle. Excellent job. You guys are typing quickly today. All right, so these are some of the formulas we have when we have known shapes or shapes that are normal, in other words. When we have these regular type shapes, we can just use these formulas, but not all the time do we encounter shapes that are just regular shapes. Sometimes they're a little bit different, and so we have to learn what we can do how we can break the problem down into parts that we do know so that we can find the whole area. Let's look at the example it has in the yellow box. Can someone read me the sentence it says under example in that yellow box? Let's see. Who's ready to read? Where it says example. The first word says separate. Anyone willing to read for us today? Sophia, I'll unmute you. Go ahead, Sophia.
Separate the complex figure into two rectangles. One is 3 inches by 7 inches. The other is 4 inches by 6 inches.
Excellent job, Sophia. Thank you very much. So if you look at that shape, you'll see that if you're just looking at the shape as a whole, it's not really a shape that we might particularly have a name for. It's a little bit weird, but if you see they added a dotted line into that shape and they broke it into two different rectangles. We have an area formula for rectangles. We know how to solve area for rectangle. So they broke the shape into two pieces that they did know, found the area of those pieces separately, and then added those together. Makes sense, right? We should break problems down into parts that we know. Okay. So, class practice says this, find the areas of the colored regions. So the first one, A, I see two shapes that I know. Which shapes do you see in letter A? Which different shapes that you know do you see in letter A? Which shapes do you see in letter A? I see two. Good. Good. I agree. I see a circle and I see a square. Okay. I'm going to try to make a representation of that on your screen. So I see something that looks like this. I see a green square that looks like this, and inside that square, I see a circle that kind of touches all edges of that square. Okay, I see something very similar to this. And then we're given one measure. We're told that from the center of the circle to the edge, that is 2.5 feet. What do we call that measure? From the center of the circle to the edge, what do we call that measure? Good, good, Anna. That's our radius. We're told that this measure is 2.5 feet. Okay, so we already said we saw that there is a square and that there is a circle. We're going to need to find the area of both and go from there. Okay, we have the radius of the circle. Can we find the area given the radius? Type in the chat box which formula we should use to find the area of the circle. Type in the chat box which formula we should use to find the area of a circle. Good. Very good. Pi times r squared. I agree. So I'm going to go ahead, always, 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 starting with the formula, A equals pi times r squared. Okay, then we can fill in what we know. What is r here? Right in the chat box. What is r here? What can I replace the letter r with? What is r? Good, Camila. 2.5. R means radius, and in the picture, we're shown that the radius is 2.5 feet. So where it says R, I can replace that with the number 2.5. Okay, I see 2.5 squared. Does that mean 2.5 times 2? I see 2.5 squared. Does that mean, Sophia's shaking her head no, and I'm so happy she's doing that. Thanks, Sophia. That does not mean 2.5 times 2. It doesn't. What does it really mean? 2.5 squared. What does that mean? What does that mean? 2.5 squared. What does that mean? Yes, very good. 2.5 times 2.5, and Sarah said to multiply it by itself. Awesome. Squared does not mean multiplied by 2. It does not mean multiply by 2. It means multiply the number by itself 2 times. So I'm going to go ahead. Maybe I don't know that one in my head, and that's okay. So I'm going to write it on the side. I know 5 times 5 is 25. I know 5 times 2 is 10, plus 2 more is 12. I'm going to put a 0 to hold place. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. I'm running out of room down here. I'm going to add it over here. 5 plus 0 is 6. 2 plus 0 is 2. 1 plus 5 is 6. Oh, why did I write a 5 there? Silly me. This is a 5. I see one digit after the decimal in the first number, and I see a second one here. So I know I need to put 2 digits in my answer. I know that 2.5 squared equals 6.25. So I can replace that. I still have to multiply that by pi. I still have to multiply that by pi. What is the value of pi? Good. Thank you, Valeria. 3.14. So I'm going to multiply that. I'm going to do that on the side here. I have 3.14 times 6.25. Set that up in your workbook and start to solve, please. 5 times 4 is 20. You can follow with me if you need help. You can work on your own if you don't. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. 0 to hold place. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. 2 zeros to hold place. 6 times 4 is 24. 6 times 3 is, I skipped one. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. And add 0, 15, 12, 16, 9, 1. I see 1, 2, 3, 4 decimals. Do the same here. 1, 2, 3, 4. I get that the area of the circle is 19.625 feet squared. Okay. Now I need to find the area of the square. Now I know the area formula for the square is A equals S squared, but I don't yet see here the side length. So I do notice I have this value here is 2.5. And I know that the shape inside the white circle is a perfect circle. And so I know that if that radius is 2.5, that means this radius must also be 2.5, and that must be equal to this side length. Do you see that? So now I see that this side here is 1 2.5 and 2 2.5s. Okay, so that makes it 5 feet in total. I know a square, given that it's a square, that all side lengths are the same. So now I can solve for area for my square by filling in 5 where it says S. I know 5 squared is 25 square feet. Okay, but the question was asking us to find the area of the colored region. Which shape in our picture here is colored? Well, I see the color green, and that represents the square. But it looks to me that it's almost as if we had this perfect square of 25 square feet, and then we cut out that center circle. Do you see that? So if we're cutting out the area of the circle, what should we do with the two numbers we have? We have that the square is 25 feet, and we have that the circle is 19.625. What do you think? What do you think? It looks like we had the green square and we cut out the inside. Do you think we're going to add the areas together or subtract them? We had the square and we cut out the inside. Which operation do you think we might use here? This one's tricky. We're going to subtract, okay? So if you can imagine this, like if I have this shape, I'm taking out the circle. So I'm literally subtracting it from the area that I had. It's the circle less than the square. So we're actually going to subtract here. I'll do that with you. We're going to take the area of the square. Get some room. The area of the square, which is 25, and we're going to subtract the area of the circle. Okay, the area of the square is 25. Now I know I need to subtract, and I notice that the area of my circle has 3 points after the decimal. So to make it a little easier for myself, I'm going to annex 3 zeros here. That makes it the same number. It just makes it a little easier for me to subtract later. Okay, that's the area of the square. I got that right here. And I'm going to subtract the area of the circle, which is 19.625. I'm going to subtract that. Because I had the circle, I had the square, and I cut out the circle and took that part out. So I'm subtracting. 0 minus 5 I can't do. I need to borrow all the way from this 5. That makes this 9, and this 10. 10 minus 5 is 5. 9 minus 2 is 7. 9 minus 6 is 3. I'm going to bring my decimal point straight down. 4 minus 9 can't do. I need to borrow again, and that gives me 14 minus 9 is 5, and 1 minus 1 is 0. So the area of just the green part is this, 5.375 feet squared. That is a tough problem. Let's try the next one. So let's look at it. It almost looks like a sideways or upside down L shape to me. And I see they added in a dotted line. It's cut into 2 different types of shapes. I see that we have 2 rectangles put together. If we're putting the 2 rectangles together in that problem, at the end, will we add them or subtract them? At the end, will we add them or subtract them when we put those 2 rectangles together? Good. Ferris got it. Anna got it. They both said add. Good. We're going to add them together at the end. Good, Ramon. In the problem A, we had to subtract, but in problem B, we're going to add. Very good, because we're putting them together. Excellent. I'm going to draw what I see. I see one rectangle that looks something like this, okay? And then I see another rectangle kind of added on that looks something like this. And when they're put together, they make a shape like this. Okay, but we're going to handle them, we're going to handle them as two separate rectangles and then add the areas together. Okay, so we first need to find all of the lengths and the widths so that we can use the area formula. Go ahead and type in the chat box the area formula of a rectangle for me, please. Write in the text box the area formula of a rectangle. That's what we always have to start with. Area formula of a rectangle. Very nice job. Excellent. Lots of you got that. Thanks, Juan David. Thanks, Daniel. Thanks, Valeria. Thanks, Anna. Thanks, Ramon. Thank you, Sarah. Thank you, Darius. Thank you, Valeria. Thank you, David. Area equals length times width. That's what we're going to start with. Okay. Now, let's look at this rectangle. So, I see it tells us this top measure from here to here is 12 meters. It tells us this side measure is 4 meters, and it tells us this side measure is 9 meters, and this side measure is 5. Now, remember, we've kind of broken it up right here so that we have those two different rectangles. So let's first, I'm going to kind of highlight in yellow. Let's look at this rectangle first. Do we have a length and a width for this rectangle? Just what's in yellow? Do we have a length and a width there? Yeah, we do. This is our length. This is our width when we're just looking at that one piece. Yeah, thanks, Camila. She got that in the chat. Very good. So remember, we're breaking it up into smaller pieces that we do know. Okay, so let's start with that yellow. So we have the length is 12 and the width is 4. Okay, so we have 12 times 4. What's 12 times 4? Write that in the chat if you know. What's 12 times 4? Write that in the chat if you know. Very good. Very good. It's 48. And we're talking about meters squared. Very good. Thank you. Okay, so now I'm going to use a different color. I'm going to use, let's say, orange. And let's talk about the other rectangle we have left. Next, we're going to talk about this rectangle. We broke this shape into two pieces we know, and now we're going to find the area. Do we have a length and a width of the orange rectangle? It's blue, but I circled it in orange. Do we have a length and a width there? Yes, we do. Very good. Very good. I see the length is 9 and the width is 5. 9 times 5 gives us 45, and we're talking about meters still. Okay, so now we have just this part is 45, and we have just this part is 48. But the question is asking us for the whole shape, all of it together. So we are going to, just like Ferris told us and Anna told us at the beginning, we're going to add those numbers together because we're adding together those two shapes. So we have 48 plus 45. We're going to add those. And both of those units are meters squared. So our unit is going to remain meter squared. So we have 8 plus 5 is 13. 4 plus 4 is 8 plus 1 is 9. So our total area of the whole shape is 93 meters squared. Now, letter C. I just have a few minutes left, so I want to go over these quickly with you. Letter C, you have a rectangle and you have a triangle. You're going to need to deduce from the side lengths you're given what the height and base of the triangle is, okay? And then you're going to need to find the area of the rectangle, find the area of the triangle, add them together. D is more like letter A. Okay, where you have this circle shape, but you cut out a triangle. So for that triangle, for the circle, you're going to find the area of the circle. Notice that it gives you diameter. So you're going to need to find radius. Okay, then notice that the triangle on letter D, you're going to have to find that area and subtract from the circle. Letter D, you need to subtract. Letter C, letter C, you're going to add. Letter D, you're going to subtract. Let's talk about letter C. I'm not going to solve it all for you, but I'm going to get you started. So I'm going to clear my screen here. Letter C, we have a shape that looks something like this. You have a rectangle, and then after that rectangle, you have a triangle that kind of looks something like this added on, but it's like full of color. So then it's told to you that the top part is 12, but this whole bottom part is 16, and then you're told this part is 8. Okay. We can assume a couple different things about this. We can assume that if this side is 8, that this side is also 8. And you're going to need to know that length to solve for the triangle. The next thing we need to find is just this length here. So we have the base of the triangle so that we can solve for the area of the triangle. Well, I noticed this. We're told this whole thing is 16, but from here to here is 12. Okay, so that leaves from here to here, which is exactly what we need to know. So the difference between 16 and 12 is 4. So this side of your triangle is 4. You're going to need that to solve. Okay, you're going to find the area of the rectangle, find the area of the triangle, add them together. Let's quickly look at D before our time runs up. So on D, you're going to need to subtract. You are given a circle. You are told the diameter is 10. And inside that circle, you have a triangle that was cut apart, cut out. Okay, so to find the height of the triangle, we know that's a radius, right? Because it's from the center of the circle all the way to the edge. That's a radius. What's the radius of this circle? If the diameter is 10, what's the radius? Diameter is 10. What's the radius?